Thomas Gallant, and today I'm going to be talking about pH titration experiments. Now, for this specific experiment, the first objective is to create a titration curve for the data that we will accumulate during the experiment. And then the second objective is to find the unknown numbers for the unknown acid that we will be getting during the experiment. Now, there are some items of need for if you want to do this experiment, and you're going to need a 50 milliliter burette, acids, acetic and hydrochloric acid, and the base sodium hydroxide, and with their specific amounts shown above. And you're going to also need a large beaker, a pH meter, hot plate with a magnet, and an unknown weak acid that you will get during the experiment. Now, the specific steps for the experiment are pretty simple. The first is to set up the beaker and the burette, so that the burette is over the beaker, so that when it drips in to the acid, when the base drips into the acid, you can record it with the pH meter, which is the second thing you set into the beaker. And then you measure the starting pH before you put in any base. And then you'll record it, and then after that you'll slowly let your sodium hydroxide go into your acetic acid or hydrochloric acid, whichever one you decide to start with first. And you'll measure every 0.2 pH. So you'll measure the volume that's dropped during it. And then you'll repeat this for both the acetic and your hydrochloric, and then your unknown, which you'll get. So now some of the results that I got from this experiment were the strong acid, which was our hydrochloric acid, and strong base, which was the sodium hydroxide, and then the weak acid, which was our acetic acid, and the strong base, which was also the sodium hydroxide again. And the reason that we can tell that these are strong and weak bases is because when we measure our starting pH, as you can see here, the starting pH for our strong acid is a lot lower than the starting pH for our weak acid. So even if we didn't know that these were strong or weak acids, and we just measure it with the pH, we'd be able to tell just by the starting pH. And now our equations. To find pKa, what we need to do was we needed to take the inflection point of our graph. So that is where the concavity changes, or where it changes from going up to going down. So it's about right in the middle, and that'll be our pKa. And then you'll take half of that, which is, so say this is about 10.4, then you'll take half of that, which will be 6.5. Around 5.5. So then you'll take that and you'll draw a straight line straight across from it to the intersection point from the graph, and that'll get you your pH. And so now back to the equations. Our experimental Ka, you'll take 10 to the negative of our pKa, which we got, which was half of the inflection point, and that'll give you your Ka for your experiment, for the experimental. And also then you have to look up the theoretical Ka, which I got from the Honors 160 manual, and you use these and then you use both of these to calculate your percent error, which is your theoretical, which is your experimental minus your theoretical divided by the theoretical, times 100, which will give you your percent error. And this one we got a 27.27% error. And then that leads us to our unknown. So this is the graph of the unknown. For this you also find the pKa by going to the inflection point, taking half of it, and then you'll find your pH by drawing your straight line across. And we can also tell if this is a weak acid because it starts around 3.8 or 4. So that would be a relatively strong weak acid. And so we calculated the pKa would be 4.95. And so we divide this by, we take the molarity times the liters to give ourselves the moles of sodium hydroxide. And then we take these moles to convert it to the moles from NaOH to the moles of our unknown. And then we take our measured unknown, divide it by our moles of the unknown, which will give us the grams per mole, or known as the molar mass. And then going back to the Honors 160 manual, we found the closest was the potassium hydrogen phthalate for our unknown acid, because what we got was 230.41 grams and it was around 204 grams. And then my application for everyday life for titrations was urinalysis. So this is used to find the blood glucose levels in diabetics, and also to show how far along a pregnancy is as well. And so that's all that, and these are my references.